In problem 5, we have a tire. We know the valve stem is at an angle of theta above the horizontal. The car is going to accelerate. We know the diameter. So we got our diameter is 0.576 meters. What we need is our radius, which is half of that. So 0.25, I'll just call it 0.27. We'll just call it that. Meters is our radius, right? Okay. We know the acceleration of the car. So we have the acceleration of the car. And here's the thing. The acceleration of the car, just like when we did the problem with the wheel, in problem 3, the acceleration of the car ends up being alpha r. And so we need alpha, the rotational acceleration of this tire, because what we're trying to get to is where is this valve stem after some time. All right, so we got our radius, we have our acceleration, and we know the radius, so we know alpha. All right, so alpha, our angular acceleration, is just a over r. Okay, we got a over r. And we want to know where is the valve stem after 11 seconds. So this is just, when you ask where something is in rotational dynamics, you're asking for the angle theta that it's at. All right, so theta is 1/2 alpha t squared, okay, plus omega naught t, which the car starts off at rest, so that is 0, great, plus theta naught. Well, theta naught, in this case, theta naught is 70.7 degrees, and we got to convert to radians, 360 degrees. So we've got theta naught, we have alpha, we have t, and we just plug it all in, and we're going to get an answer. Now, when you state your answer in degrees on this problem, you want it to be between 0 and 360 degrees. So you're going to get this in radians. That's going to yield radians. And you're going to do 360 degrees over 2 pi radians to get to degrees. How do you then convert from the number of degrees, the number of degrees you need to be at in this, right? Because you're going to get an answer that's something like, let me just make one up. You're going to get an answer that's, so I'll make one up that I can do all the math in my head. 36,025 degrees. 36,025 degrees. But I want an answer between 0 and 360. So what is the answer in this case? Well, one rotation is 360 degrees, right? So how many times will 360 go into this? You can figure this out in a variety of different ways. But the first thing is, I'm going to divide this by 360. And what am I going to get? All right, I'm going to do theta over 360. And I'm going to get 10 point something. Well, I'm going to subtract out all 10 of those rotations. So theta is 36,025 degrees minus 336,000 degrees, those 10 rotations. And now I get what's left is just that 25 degrees. And that's what I'm after. Where is it? It's at 25 degrees. It's gone around and around and around, and now it's at 25 degrees. And that's how you solve this problem.